Elizabeth?
Echo.
Elizabeth Marini, yes.
Echo.
Libby? Okay. And Marissa? Ian? Cameron?
Yep. You can call me Cameron. Doesn't matter.
Cameron, okay, good. Tegan? Stephanie? Brianna?
Call me Bree.
Bree? Marlin?
Marlene.
Marlin.
You can call me Marmar.
Marmar?
Yeah.
Harrison? Kane? And Diana. Okay, I'll try my best to keep track of names and nicknames and pronunciations. But thank you. Just please remind me, and I'll keep trying. So today we're going to. Oh, I looked at the information sheets that everybody gave. Right? So very useful to have this. Some have taken AP statistics or some statistics before, but the majority has not. About half or a little bit more have taken calculus, but a substantial number have not. Programming, not many mention much experience with programming, maybe doing some MATLAB from a calculus course or Excel or a little bit of this, a little bit of that. But not a lot of background. We're all kind of on the common level there, the use of the computer and so on will build up as we go along, so it's good to have that information. In terms of the interests, I've tried to make a list, and then it just kept getting all these individual categories. Everybody, there was some repetition. Genetics, medicine, environmental science were more common, but neuroscience, developmental biology, botany, animal studies, animal biology, fisheries, marine biology, and then other topics came up as well. So we'll see a lot of examples. The book has a lot of medical examples and kind of lab biology type examples. We'll supplement those from wildlife biology, from other areas, from other different types of surveys. So hopefully I'll keep this list and look back at it periodically, and try to keep a nice mix of examples, because like I said, for me the statistics and probability has a lot of application, and it can be useful in a lot of the fields that you go into. So it was interesting to learn a little bit more about that. I'm sure I'll learn more about you as we go along. So homework 1 is posted on the website under assignment. It has, so our textbook doesn't do as much talking about what is an experiment, what are the elements of an experiment or a survey. We'll talk about that today and then Friday in class. And so some of it is reading the descriptions of the problems that are on there. The wording of the problems is a bit longer because I'm not only asking things in the book, but kind of elaboration. Usually those can be written with short answers and just response to the topic that's there. But that's available. It's due next Wednesday, so you can start looking at parts of it for experiments now, or surveys we'll talk about today, and then Friday on experiments, and then we finish up with describing some categorical data on Monday. So if you do parts of it, by Friday we will cover about two-thirds of it. So there, has anybody seen any surveys in the newspaper recently? So over break, Burlington Free Press is our local newspaper, right? There was reports of a number of surveys. There was one description of a survey today in the paper. So this is from December 11th, right? Data showing a link between childhood trauma and adult health. Right, so this is a 2016 survey by Centers for Disease Control, and the individuals who reported, retrospectively that they had some childhood trauma or some extreme event, their health conditions were, they had some health problems relative to others. Right, so it's a big national survey, large sample size, and asking about some of these retrospective. Right, so it's a survey of health. Right? A second one, that's not, this one was a survey there's a survey that says several Vermont bumblebee populations are declining, right? So how would they do this, know that? How would they know that they're declining, right? They have areas where they go and sample, where the bumblebees are living. They visit them periodically, make measurements, and see over time from those samples. They can't collect all the bumblebees, get them to line up to be counted or anything like that. Right? So they have to sample in different environmental areas and do that. The other survey that was in today's, it was just a little mention that they were going to start surveys of fishermen or anglers on a lake, the Mimifrog that crosses from northern Vermont into Canada. Right? They're going to go out on the ice and interview people ice fishing out there over the course of a 2-year period. On both the Canadian side, it's news because it's a Canadian-U.S. joint venture to interview people and find out what they're doing, how much fish they're catching, whether they're being safe or following the laws or have permits or something. But they're going to know something about the use of that lake and what people are doing based on that. There's another one. Probably can't read all these, right? But there's been a study going on tracking individuals who graduated from high school in Vermont in 2012. Right? So there's an ongoing study finding disparities among nearly 6,000 Vermonters who graduated in 2012. Right? In terms of whether they went on to get other degrees, whether they went on to employment. 6,000 happens to be the population that graduates from high school in Vermont each year. That's there's some high schools in other states that are almost that size by themselves, but that's the entire population. So this is actually a census. So it actually had everybody, and they follow to see if those people are enrolled. I don't know if they'd be able to get, and from how they do it exactly, how they get information on all their educational attainment or all their employment. So there must be some attrition or some effort at following individuals, but anyway, it's kind of trying to study that population. So these things come up all the time, and form a key part of the public health network in the United States in terms of monitoring health. There's a few large surveys that are done all the time. The Centers for Disease Control, there's a National Center for Health Statistics. With government, you often get a lot of acronyms for things, and there's a National Health and Nutrition Examination Survey. That goes on every month. There's a National Failing Health Interview Survey. Let's see if this one just looks better. Oh, that's worse. Sorry. I need to update my markers. But there's a National Health Interview Survey, and there's many other surveys, risk factor surveillance surveys that go on all the time that provide the key estimates of trends in public health, are people getting heavier, is diabetes increasing, are rates of cancer, what's going, what's the flu epidemic look like this year, are going on. And they all use random selection in some form to avoid a selection bias. So today we want to try to understand that process of random selection and why you might have some selection bias. So the big overview of surveys is that you're interested in studying some population. Right? And often that's called a target population, where you're selecting the subset of the population that you can actually feasibly try to study. Sometimes it's very difficult to study the entire population, and for some reasons you might need to restrict it. Right? Some of those honeybees might live in very remote areas or very rugged areas that it's difficult to sample and monitor, and so they might not be included. And some individuals in the human population are very difficult to interview. Some are in prisons, some are in mental institutions, some are in the armed forces and overseas, and the military does its own surveys of its own people, but for other surveys you might not have access to them. Some people are homeless, and with the resources. For some surveys, it might be difficult to go and ask them questions and visit them. Of course, they should be documented and their health and everything should be concerned, but within the scope of one survey, it might be beyond the reach of some efforts. So then there's a selection of a sample of individuals for data collection. Those people are picked. How you pick it is called the sampling scheme or the sampling rules. And the goal is to describe the entire estimate something about the entire population based on this smaller sample. If in the United States there's 200 million adults, most of these large government surveys can't get past 10 or 20,000 people because it just costs too much and it's too time consuming to have any more in there. Right? The highest quality surveys use some random selection under control of the researchers, that you have your list of your population or kind of your conceptual enumeration of the population, and you randomly pick individuals from that, and those people that you pick, you go and try and get information from. Efforts to contact people might involve postcards and letters and phone calls, maybe a dozen phone calls. Some surveys use home visits, up to 5 or 6 different home visits to try and find people, to actually get those people to respond. Right? Others are not quite that expansive in their efforts, but it could be a multi-step procedure to try and get those people to respond. So if you have your population and you randomly pick people and you get responses from those people, on average, those people that you've gotten responses should be representative of the population. They shouldn't be older on average or younger on average or different race ethnic composition, same balance male female. They shouldn't differ in education attainment, right? But they should be all those things. There's no reason, if it's randomly selected, say from a computer, that you would tend to favor one group over another. Efforts in surveys are made to limit other biases. A lot of incentives and other things are made done to help people, encourage people to respond. This is an important topic. We'll give you $5. And so on. It's a quick survey. There's a whole industry within cognitive psychology of how do people respond to questions and letters, and it's partly connected to marketing as well. How will people perceive this? What will encourage them to do that? What will make it easy for them to answer questions? There's really some, a psychology about how people remember things and think about things. If I ask you a question, right, about what's happened in the last year versus in the last month versus in the last week, there's different processes of recalling that information and kind of estimating when things happen. There's some issues. Some topics are sensitive and people don't necessarily want to talk about problems that they might have or things that they might be doing that might be socially undesirable. And so a lot of effort goes into making those things happen. Right? Other topics, if you go into public health, you might really study some of those things in depth. A couple different ways are done. It's not usually just a simple random sample. Usually there's some division of the population and things, but we'll talk about those as we go along, right? And so in planning a survey, on the handout that you have there, give some steps. So let's think about these steps in an actual context. Right? So in terms of health, we could think about randomly picking people, wanting to describe the health status of people. What's the average body mass index? What's the things like how much do people smoke or drink? How much sugar are people consuming? What are blood pressures? And so on. So let's imagine that we want to do a health survey. And then just talk through a few of the steps that we might need to do to actually make that happen. So we've been gathering data on people. There's a pretty strong division between children and adults. That adults can give consent to participate for themselves, but generally children are protected. They have to be treated differently, and some adult has to agree that it's okay for them to do it. So it's harder to do studies on children, even though it's important. Right? So let's first talk about a population that you might want to do. Right? So let's do a survey of adults. Right? So adults ages 18 plus, 18 or more, right? We need to have some way of sampling from them, right? So the population that we would like to know, we would like to know about all adults, right? But sometimes there's a restriction process where we talk about a target population or the population you could actually survey that might be a restriction. Right? We mentioned that some people are not available for surveys. One restriction could be that we want to do adults and households. That would leave out an important part of the population, or leave out those who are homeless, who don't have a fixed house. That would be a deficit, that would be a problem. You would want, some other agency or some other survey might focus on individuals that are in homeless shelters or in the woods or some other type of arrangement, right? To ask them, migrant status, that people would be monitoring their health. That'd be worthy of survey, but for the point of view of setting up one survey, sometimes you make it more concrete. You could limit it to households. Then a survey frame or a list, right, is a list of the units in the population. And in some cases, we can actually have a physical list, right? So that survey of, that study of Vermont high school graduates, they graduated from public schools in Vermont, presumably they would have a record of all those individuals, so you have a list. How about in this case? Is there one list of all the adults in the United States? No, there's no such thing. We don't have a population registry. Some countries in Europe and other places do have population registries. They, Denmark, Sweden, Norway, they do have population registries. So when you move, you do register with the officials, and they know where people are. They've kind of given up on doing some census and surveys because they can actually contact everybody in any case. But ours doesn't. So you have to. There's not really a list of individuals. It's easier to list households. There's a few organizations that actually list households in the United States. The Postal Service does, the delivery addresses, and they know a lot about that. Right? There's a delivery sequence file that says how the post is supposed to be delivered across there. It's supposed to list all mailable addresses in the United States. Right? The Census Bureau has maps, topologically geo-referenced integrated maps they use for counting the population. There's other big companies that keep track of this thing. Right? The Postal Service is public records, it's not private information, and so some of these companies can get that information, and then they can keep updating it monthly. And some other big companies actually send people out, like the ones that do the multi-million-dollar surveys, actually send people to different locations to enumerate addresses and look for new construction, or see if buildings have been burned down or torn down, or evidence that they've split addresses and there's people living on multiple levels. So there are lists of households that way. Beyond that, you can have a list of areas. Right? You can get geographic maps of the United States and map every block. And Google Maps and other things, you can find the households, or at least conceptually say, here's this quarter square mile or smaller area, and I can pick that physical area. Right? The sampling scheme is how a sample is picked, from the frame. How are you going to go about picking out which individuals go into that sample? So say you had to ask questions about health of individuals, and you were supposed to get a sample of individuals from Vermont, and you went to the University Mall here in Burlington, and went inside and just stopped 100 people and asked them questions about their health and completed the survey. Would that be representative of the entire state? Why would that not be representative of the entire state, for example? Yes?
Not everyone goes to the University Mall.
Not everybody goes there. Who goes there?
College students.
College students, high school, middle school students go there, but so not everybody goes there, right? And the people that go there might be systematically different, kind of different on average than the general population. There could be different economics conditions of the people going there. Right? There could be different computer literacy. I don't know. I mean, if some people order everything online and do everything on the computer and don't go to the physical mall, like the people that are doing that might be different from the people that actually still go to the mall for that. Right? There might be something about, certainly about where they live. Right? They're not going to drive from the Northeast Kingdom or Southern Vermont just to go there. Right? And the people that live in different areas could be different in terms of their background, in terms of their economics, in terms of their health status. Right? To go to the mall, I mean, people have these carts that drive them around, little scooters, but largely it's a walking exercise. So there might be some real health difference between the people there. Individuals who are 80s, 90s, there might be some health impediments to going there. So their health conditions of the people that are walking actively around the mall might be different. Right? It's kind of at that systematic difference between the people who get selected versus the ones that don't. That's the real issue when you try to describe the entire population. Right? And who are you going to talk to in the mall? Is everybody equally friendly? Is everybody equally busy? Some people will be just kind of lounging around and they'd be glad to have that experience of talking to an interviewer or doing a few questions. But other people will be, in and out. Right? And there might be some differences between the health and other aspects of the people that are easy to talk to and the ones that are not. So if you're giving your free reign of choosing people and you're paid to do 100 interviews, my bet is you'll get those done faster if you take the most convenient people that are coming along. Right? Time is also a difference. Who can go in the middle of the day versus the morning versus the evening. Right? So surveys like that kind of informal ones like that, for a particular business, it might get some useful feedback from its customers. It could serve some purpose, but it's not quite the same as describing the whole population. Right? So there's nothing wrong inherently with getting information that way, but it's just, you wouldn't want to claim that you generated the whole thing. So one probability sample is when you take a sample and the sample is chosen randomly. And that random selection process is under the control of the researcher. That the person designing the study gets to do the random picking. Of the researcher, right? Once you are picking these, say we pick households randomly, we have to contact them. In the world of survey sampling and health, there's major corporations that do hundreds of millions of dollars of business with the federal government and other institutions to do these surveys. Right? They have to think about postcards to get people, what they've been doing largely kind of over the last 5-10 years is sending postcards with website links. right, in them. Now they're sending them with the little digital phone things where you point your phone at it and it pops to a website. So somebody gets one of those, they point the phone at it, boom, the survey's right there. Right? So that makes it easier for people to get into it and do the survey. Right? So postcards, sometimes they send letters with the survey, mail the survey, mail the general thing there. Other times, people that don't respond, some surveys, they really want to get responses about things, so they might use telephone. At one time, before you were born, and maybe by the time you were born, people still had landline phones in their houses, right? And back in the 1950s and 60s, 1950s, 1960s, they did. A lot of the rural areas or poor areas didn't have their own phone. So you couldn't sample based on that. But then the 70s, 80s, 90s, the phone saturation became almost complete. And you could random sample from the white pages of a phone book and get just about every household. But then people started refusing to have their numbers listed, put on do not calls. Answering machines came along, and suddenly you can't reach people that way. Right? And now people have cell phones, so doing phone surveys and has become harder, and there's certain restrictions on dialing cell phones. People use cell phones at times when it might not be safe to have a long conversation, like when they're driving or something like that. But you might still contact people by phone. In person. Some surveys, current population survey and our big health surveys actually send people to have other addresses. It's terribly expensive to do that, but if you really want to get the national response of everybody and cover all aspects of the population, there's part of the population you're not going to reach through other things, right? You contact, yeah, that's right. And then people respond. So the response, they might respond via mail, phone, or maybe in person. Internet, of course. Internet. It's still a little bit hard to contact people versus internet. I mean, you can survey, say, a group of students. You have a student population, you want to get information from them. Often the response to those emails is just horrible, like, less than 10%, less than 1% in some cases, sending, and then people need to respond, and then statistical estimation happens. Where you take the sample summaries and you generalize to the population. You might be reporting an average, and so on, and getting that information. So in terms of these topics, so the sampling scheme is how we picked, the estimation strategy, given the information that's there. It might be averages, proportions, or other statistical things, using some of the regression and other things that we'll do towards the end of this course. It can be more. And then plans for dealing with other problems, trying to get people to respond, dealing with quality. If you're having health measures being recorded, you want to make sure that all the individuals who are recording the information are doing it the same way. That somebody records blood pressure, that there's not a difference because somebody's doing it down here or somebody's doing it up here, that they're recording height with the shoes on or shoes off, or they're maintaining hearts. There's heart rate monitors. There's a question of placing them properly on individuals of different size and body composition to get an accurate measurement. And if that's part of your scientific study, there's training that goes into that process to make sure people are doing it the same way. Right. So by probability sampling, randomly picking people, it deals with this selection bias. Selection bias on the next page is if people are included in the sample because they choose to participate or because they are purposely chosen, rather than because they were randomly chosen, then there could be selection bias. If you go out and get just certain people, it's hard to get a representative sample, something that's really representative of the population. It's not biased in one characteristic or another. Right? So the selection bias occurs when those participating deal in some systematic way on something that you're measuring from the people who are not participating. Right? And the random selection should avoid that. We're going to talk more about that But there's a couple other things that go on, right, in large-scale surveys besides just simple random sampling. So I guess I should say that. One sampling scheme is just called simple random sampling, or a simple random sample. So a simple random sample is just when every sample of a certain size from the population is given the same chance of happening. Right? So the population size is capital N, and our sample size, how many people we're going to pick in the population, is the number little n, that's smaller than that. Right? A simple random sample happens, so each sample of that size, of that many units, n, has the same chance of being chosen. And one way to do that in practice is if you could list everybody in the population, put their name on a little piece of paper with a little chit or a token, and then put it into a big hat, right? And then mix them all up, completely mix them so that there's no residual order to it, and then reach in and randomly pick one out and record that name. And then mix all the rest up, pick out another one until you've done that little n times, and you get your numbers, right? So you could get all the possible samples of size n. No one should be favored over the other, and you could show that they would have the same probability of selecting any of those particular samples. Usually we don't write down all the names of 300 million people or 250 million adults. On that, we have a computer database, and the computer can do random selection. Right? And the computer can generate random numbers. Right? It's kind of really pseudo-random numbers. They're numbers that are generated by an algorithm that look random and pass tests for randomness, and for all intents and purposes, we think of them as random, but they're really generated under a certain thing. Right? And then for the sample, you can report the average, right, or sample proportion, or other statistics that would summarize the information there and use that as our estimates of what's going on in the population. But usually there's a little bit more structure in a large-scale population. Even if I was going to design a survey of students at St. Michael's, I would use what's called stratification. I would divide the population up into groups and take samples within those homogeneous groups. So a stratified sample is divide the population into strata, which is one form of making groups in the population, and then take a sample, take a simple random sample in each stratum. And so that choose a sample size in each stratum and take these individual samples. Right? What this does is introduce more control in the sampling process. You're not allowing it to be random how many freshmen, first year, second year, third year, and seniors you get in your sample, but maybe you're taking 100 of each. Right? You're forcing that particular control on it. You're not allowing it to be low in one category and high in the other, but taking that control. And this extra control leads to less variability once you combine all the data, when estimating the overall total or overall average. So generally, it leads to less variability because you put in that more explicit control. So last year, and continuing this year, I've been involved in one survey the U.S. Veterans Administration. There are about 8.7 million veterans in their health care system in the United States. And they wanted to take a survey every year of individuals, veterans in the care and ask them questions. Have they used mental health services? Have they used outpatient services? Have they used diet services? What is the general state of their health? You know, and a number of other things. And so that's the population size. The sample size that they took last year was 42,000 people. But they didn't just take a simple random sample of 42,000 from the entire population. They used stratification. Within the veterans health care system, there's 96 different health care markets. Roughly, these are geographical. About 1 or 2 per state, maybe 3 for some of the bigger states. Right? So states like Wyoming or Nebraska or Vermont have, it's one healthcare market. Maybe Vermont and New Hampshire combined, I'm not sure. Right? But for big cities, like New York City might be one, New York State might be another, Chicago, Dallas, and so on, might have their own market, and then the areas around them are there. But they wanted to be able to say something about every single healthcare market. Some of these are very large. Some of them are quite a bit smaller. You know, Hawaii, Alaska, some of the islands, some states, you know, Wyoming, Vermont. They don't have many people in comparison to many other states. So if you just sampled randomly, there's a chance in some of those states you would end up with just, you know, 100 people or less. Right? And so for estimating in that state would not be very good. It would be highly variable. You wouldn't be reliable. So they really did separate samples in each market. And each one had 350 or more people in it. In each one. They actually divided the sample in more ways because there were different veterans with different health priorities based on their known conditions and different, were they involved in military campaigns in the last 20 years or not. And so there's a bunch of ways of dividing the veterans, and they took essentially different samples inside of each one of those. Right? That level of control produces a lot of stability. But if you took a different sample, it would still match those same characteristics and not have that source of variability. So overall, it's more precise. But they have a list of all the veterans. They have their often emails, phone numbers, addresses, and so they can try and pick them and contact them. So with a random sampling avoids the selection bias, but the stratification provides more control and more precision. And they ask a bunch of different healthcare questions. But any questions about surveys and kind of the description of the processes that are going on? Now, another way that surveys are designed is often there are clusters in the population. And when you're dealing with healthcare, you're dealing with families, if you're dealing with hospitals, or you're dealing with children, if you're dealing with wildlife, you're dealing with populations that live together. So there's clusters. So the population is structured in clusters. Then a cluster sample, or clusters, you randomly pick clusters. Of units. And then take measurements on some units in the selected clusters. this can sound like stratification because there's groups and then you sample groups. The difference here is that we only pick some of the clusters. So maybe you only pick some of the households. You don't go to every household. And within each household, there could be multiple adults, multiple children. So you pick a household and then you gather data on everybody in that household. So that's a cluster. And it's a very natural way to go about contacting the population and then gathering data. Its clustering has the advantage of convenience. The population might be structured that way. You go to one site or one group and you get a bunch of data from that, right, instead of doing random individuals all over the place. So it can have some convenience to it. But it tends to increase variability, increase variance. Because the individuals you get really are not completely independent of one another. They're in the same household or they're in the same area. Right? So they're more like each other than random people. So there's a trade-off, convenience and cost versus this variance. Usually these things are used together. There's a stratified population and then you cluster a sample of households and so on. So it gets more complex. The field of survey sampling and survey methodology deals with this stuff in depth. And there's a lot of companies and government agencies at the local, state, and federal level, and national level in other countries as well that do these. So one place that cluster sampling is often used is in environmental sampling. If you go out in the field, you don't want to pick this spot and this spot and this spot and have to trape all over the place. Right? It's much easier to go out to this field and take 3 sample points. So one big study that does that is called the National Resource Inventory Study. It is a survey of all the land area in the United States. And it's been going on since the 1950s. And this is the survey that they use to estimate how much land we have in wetlands, how much land we have in rivers, how much land we have in prime arable farmland, how much is urban, how much area do we have in cemeteries, and how much do we have in railroads and everything else. What percent of the land area in the United States is planted in corn or soybeans, or how much honey production hives are there located in Vermont. So it's a huge survey. And it's a stratified cluster sample. So the strata, for some simplification, can be thought of as counties. There are 3,000 some counties in the United States. It does a survey in every county. And then it uses clusters. So a square mile section is sampled. Right? So they have a map of the United States. In every county, you have all the land area. It's broken out into 1 mile sections. In some states like Iowa and Nebraska, the roads are actually placed in 1 mile intersections because it's nice and flat and easy. That's how it was organized. But around here, it's more chaotic. Right? And then they go to, they actually collect detailed data in a number of ways, a number of government records and things. But they would collect environmental data by going out to the site, or taking soil measurements and other measurements and other observations at points within the clusters. So if this is, this is kind of Nebraska. Nebraska kind of looks like that, and there's some counties that are out here. So in that county, it would go out inside of that county. It would pick some square mile sections, and inside of each of these square mile sections, it would collect data in a few points. Right? And then they take all that information and sum it back up, weight it by its sizes and things like that to represent the entire United States. So they don't have to drive all over the county, going to these different places. They just have to go to 3, and then they take measurements that are close together that they can do kind of fast. So again, it would be probably more efficient if they could take random points all over the United States, but it would be operationally infeasible to do that because of the travel time distances to do that. So anyway, a lot of interesting things happen with those. We're going to do an exercise to finish off today to kind of get some appreciation of selection and sampling and some of the benefits of random selection. But any questions before we? This study has, you can look up that on the internet, and as long as the government web pages are open, it has a ton of information about the thousands of things that they measure and estimate out of that. So we're going to look at an example called random rectangles. It comes from a book called Activity-Based Statistics classes, and if you took AP Statistics, some AP Statistics places use this, and the idea is that I'm going to show you a picture of 100 rectangles, okay? And the rectangles have different sizes. So this one would have an area of this one. If you get 3 like this, it's an area of 3. If you get a square, right, this is going to have an area of 4. If you get bigger ones, 1, 2, 3 line, it's 4 by 4. So that's an area of 16 squares that are in there. And the goal is to estimate the average size across this population of 100 rectangles. And so first I'm going to show you the picture. I'm just going to show it to you quickly. Right? And you're going to look at it and try to guess what it is. Right? And write your number down there. If you think the average is 2 or 10 or 20 or whatever, right? You're just going to look at it and try to get the impression. That would be an example of not really sampling that much, kind of just being kind of haphazard, taking whatever experience is there. Right? Then we'll do it a couple different ways. Right? So I'll show you, and then we'll record the data to try to see what the averages are. Right? So any questions about this counting, determining this? Right? So if it's 3 by 5 on a side, it's 15, right? 2 by 3 on a side, it'd be 6, and so on, so the areas. Right? So this is the picture, I think. Right? So here's the picture of the rectangles, and it's a little bit small. I didn't fully appreciate how small it would look there. So you do your best to see it. If you need to move up from the back, you could come up a little bit just for this, right? So there's the 100 rectangles. What do you think is the average area, average number of little squares in those? All right, so you've seen it. This is actually something, RStudio. This is kind of the format that we have there. So what I can do with this is just enter data. This is one way to enter data, one format that can work for entering some data. So why don't you tell me what your answers are, your guess. So why don't we just go down the rows. And so Leah, what did you guess?
I said probably around 8.
Around 8. 7. 9.
8.
8. 7. So why don't we go back? Yes.
5.
5. Okay. Oops. 5.
8.
8.
7.
7.
9.
9.
8.
Okay. 8. We're coming down now. Yeah.
7.
7.
7.
7. Yeah.
9.
9. Yeah.
10.
10.
8.
8.
9.
9.
8.
8. Okay.
8. 11.
11.
8.
8. Okay. Yes.
8.
You say 8 and
10.
8 and 10. Good. So mean reports the sample average. Oops, that's not there. So 8.13 is our average, doing it this way. So we're going to look at it a little bit longer, right? And what you can do is pick out some rectangles, say 5 rectangles, right? Write down their area, right? And take the average of those, right? So if you write down 5 areas, you would add them up, right, and divide by 5, take that sample average. So you can pick 5 that you think would be a good representation of the sample, right? And do it that way. So each rectangle has a little number on it, and those numbers just go through 100. So we're not writing down those numbers at this point, but it's just the number of squares and the areas. Right? So here it is. Go ahead and pick 5. Actually write down the areas of your 5 and take an average. How's that going? We have 5 numbers written down. We'll start recording some of these. So we'll give that another name, revised 2. I wanted to change that other thing. But what did you get for the new one?
8.4.
8.4.
8.7.
8.7.
9.4.
9.4.
9.4.
9.4, okay.
11.4.
11.4. And then, yes, here in the front.
5.2.
5.2. Oops.
8.2.
2.
7.6.
6.
8.2.
2.
7.
7. Okay. Even. 10. Yeah.
9.
12.0.
12.0. Okay.
5.2.
5.2. Okay.
7.
7.
11.4.
4.
8.6.
6. How did we go before? Did you go next?
12.
12.
8.8.
8.8.
9.8.
9.8. 9.8. Yes.
8.8.
10.8?
8.8.
8.8. All right.
10.
10. Right. So how did this go? What's the average of these? Right, revised 2. So a little bit higher, right, than that. Right? So a way to take random selections would be to give each of you random numbers. And we can do that on the computer. We did it once before. Right? So what this, maybe we can do a few more. We'll do is generate 100 numbers between, or yeah, a whole bunch of numbers between 1 and 100 and put them in 5 columns. Right? So when I do this, you get this here, right? And so these are 5 randomly generated numbers, and that would be like your sample numbers. Oh, I happen to get 89 twice, right? So this is sampling with replacement in this. So I guess this person, we get the first one. You get to use the rectangle 89 twice in your sample, right? Usually when we sample in human populations or other things, we do it without replacement, so we wouldn't have that duplicate. But some sampling does happen with replacement in a few cases. If you take a course in survey sampling, that would be one option that's considered for certain things. And so the rectangles have those numbers. So you need to write down your random numbers. So each person gets a row, right? And I think you can be row 1, you can be row 2. So write down those in row 3 and row 4, 5, 6, row 7, 8, 9, and 10, 11, and 12, and 13, and 14. And row 15, so your random numbers are like these, and 16, and 17, and 18, 19, 20, 21, 22. Can you see the lower numbers down there? So everybody gets 5 numbers. Write down those 5. And then we'll try to look those up on the population. Everybody got their 5 numbers. Let's start searching for these. They're roughly organized from 1 to 100, from the top left to the bottom right. Sometimes you have to look around a little bit to find the numbers. And we're not recording the numbers themselves, but the number squares, like 1, 4, 12, and so on. So record those for these 5 that have been selected for you. If you need to come up and look at it quickly to get it better, that's fine. I don't think I can see it from the back anymore. But I didn't want to hand it out because people would spend time looking at it beforehand and get some other idea. So. Are you looking for any?
I have a line. I have like 2 because on lines I just can't.
Oh yeah, right. So when you get those 5 areas, add them up and divide by 5, and that'll be our number. All right, let's record those. Everybody good with that? So I guess we'll just call this, I'll call that my estimated. Second one, so what did you get for that?
6.2.
6.2,
4.4.
4.4,
4.8.
9.2.
4.8,
6.0.
okay. Yes.
7.6.
6.6,
6.2.
6.2,
8.8.
8.8?
6.8.
6.8.
9.0.
And so yes,
5.8.
5.8. 9? What did you get? Oh, that's your turn, yes.
Oh, 6.6.
7.2.
2,
7.4.
7.4, and what did you get here in the front row?
Oh.
Did you get one?
Me?
Yeah,
Like an average of all 5.
yep.
I got 18.6.
Probably not the, that's probably too high given those, right? So if you get the area, and
the actual.
the actual area of those, did you add up the numbers or something in there?
I just added the numbers that I got.
Oh, okay, yeah,
Yeah.
yeah. So we were looking for the areas in there. No, that's fine. So that is a larger number, yeah. So next, yes.
I got 2.4.
2.4,
12.4.
12.4,
8.4.
11.2.
Okay,
4.
4,
6.6.
6.6,
4.6.
4.6, right? Do those look much different? A little bit lower, right? So the first time we got 8.1 and 8.9, right? And now we get about 6.9. The answer is a little bit above 7, actually. Right? So the explanation that they give in the study materials is that there's actually a lot of ones and small ones spread out through there. And if you're picking your own, you tend to kind of balance out where you take more of some small ones, some medium ones, some large ones. People tend to pick the large ones a little bit more than their share of times that they come up. The small ones kind of get lost in the shuffle. So even though you're trying to do a really good job and getting pretty accurate, on average it's still a little bit off. Sampling, there is variability because every random sample can be a little bit different. But the controlled random selection can remove some of that selection bias, but it's hard to avoid even if you're trying to actively avoid it. And in cases where it's there's more motivation for only certain people to respond, it can be a bigger effect. On Friday, we'll look at some experiments and some principles and kind of things.
Thank you.
So I'm on the student here and I have the letter read, but on Friday's class, I was, yeah.
These guys are very good at it.
Okay, so Friday's class is a home meet, and I just have to be in our pool warming up at 3 o'clock.
Okay.
So would I be able to leave like 10 minutes early,
Yeah,
if
sure.
that's okay?
Yeah.
All right, do you want this, or?
I'll go ahead and sign it.
I mean, I don't have to
Or you-
turn it in anywhere.
Yeah. Well, I'll just go ahead, just so that just in case,
Okay,
since it's here.
yeah,
No, that's fine.
yeah,
You're swimming at home, you can sing photos.
yeah. Well, this meet,
What do you swim?
I do backstroke in
Uh-huh.
the medley, individual medley, so like all the strokes together.
Okay.
Yeah, we have a meet on Sunday that might get canceled from the snow at St. Lawrence, so. Yeah, our season's almost over, so that's like the only like one time I would possibly have like a class conflict, but thank you so
Sure.
much.
Girls do swimming in the summertime.
Oh, really? Do they do that,
Test. So Essex, town of Essex swimming pool.
Oh, okay,
Well,
yeah.
One swam some for the GMA.
Yeah.
Here at St. Michael's.
Yeah, GMA, they practice here, and their coach and our coach kind of work together a little bit, so. Yeah, I've been doing it since I was like 11, and I liked it, so it was something to do, and it was a good like extracurricular to have throughout, so.
Yeah.
Tell them to
It's
keep
good
it up.
conditioning, yeah.
Thank you.
Thanks.